All right, let's talk about a mathematical riddle that is so simple a kid can understand it, but so incredibly hard it's been called dangerous. Seriously, it's a problem that has left some of the smartest people on the planet completely stumped for decades, and it all begins with a pretty wild question.
So just think about that for a second. What if a puzzle, with rules you could explain in under a minute, was hiding a secret that even our most powerful computers and brilliant mathematicians just can't crack? Well, that's the bizarre paradox we're diving into today.
So let's get right into it. The beauty of this thing, and maybe the scary part, is just how simple the rules are. You don't need any fancy math, no complex equations, it's just basic arithmetic.
That's it. Those are the rules. You pick a number, any positive whole number you want. If it's even, you just chop it in half. If it's odd, you triple it and add 1. And then you just do it again with your new number. And again, and again. You could literally start doing this right now on a napkin.
Now here's the big idea, the thing that's driving everyone crazy. It's called the Collatz Conjecture. And the prediction is that it doesn't matter what number you start with, a tiny number, a gigantic one. You are always going to end up at 1. It feels like it has to be true, but nobody, and I mean nobody, can prove it. So to get a handle on the totally bizarre way these numbers act, mathematicians came up with this really great metaphor. They call them hailstone numbers. Why? Because their journey is a lot like a real hailstone getting tossed around in a storm cloud. It shoots way up, gets thrown way down, before it finally crashes to the ground. Okay, so let's actually watch one of these hailstones in action. The number 27 is kind of famous in these circles because it's a real troublemaker. Instead of just falling down nicely, it decides to go on this absolutely wild ride first. So let's follow it.
So you start with 27. It bounces around a little bit, but then something totally unexpected happens. It starts to climb, and I mean, it really starts to climb. After 77 steps, it just skyrockets all the way up to its peak at 9,232. This is the chaos we're talking about, this explosive, totally unpredictable jump from such a small starting point.
But after that insane climb to over 9,000, the sequence for 27 finally runs out of steam. It starts to fall, just like that hailstone, tumbling back down, down through the numbers. And where does it finally land? Right here. It hits the number 4. Well, 4 is even, so that becomes 2. 2 is even, that becomes 1. 1 is odd, so you do 3 times 1 plus 1, and you're back at 4. You're trapped. It's the 4-2-1 loop, and it goes on forever. And here's the thing. Every single number we've ever checked ends up right here. When a problem this simple refuses to be solved for this long, it starts to get a bit of a reputation. The 3n+1 problem isn't just some cute puzzle. Among mathematicians, it's known as a career killer, a problem that has fought off attacks from the most brilliant people alive. And that really is the mystery, isn't it? It feels like our best mathematical tools just break when they get near this thing. The rules are so straightforward. You go up or you go down. But we have no way to predict the path ahead of time. All we can do is follow along, one step at a time. We can see what happens, but we have no earthly idea why. This quote, this comes from one of the most legendary mathematicians of all time, Paul Erdos. He actually warned other mathematicians to stay away from this problem. He basically said that we, as a species, haven't even invented the kind of math we would need to solve it yet. Just let that sink in. This isn't about one person failing. It's a gap in our entire understanding of numbers. But here's where it gets even weirder. The Collatz Conjecture doesn't seem to be some isolated fluke. It actually feels like it's part of a much bigger pattern in the universe. This kind of tension between complete chaos and some kind of deep, hidden order that we see in other places too. For example, have you ever heard of Benford's law? It's this bizarrely accurate rule that predicts the first digit of numbers in real-world data, like from stock prices to the populations of cities. It's another example of a surprising order hiding right under the surface of what looks like total randomness. The Collatz problem feels like it's tapping into that same kind of deep, mysterious structure of the universe.
So let's circle back to the central mystery here. If the conjecture is wrong, if not every number falls down to 1, then what else could possibly be happening? Where else could these numbers go?
Well, for the whole thing to be false, one of two things would have to be true. First, there could be some number out there that just never comes down. It just keeps getting bigger and bigger and bigger, flying off toward infinity forever. Or, second, there might be another loop, like the 4-2-1 loop, hiding somewhere out in the endless ocean of numbers, and we just haven't found it yet.
And this really gets to the core of what math is all about, the difference between evidence and proof.
With computers, we have checked numbers up to 2 to the 68th power. That's a number with 21 digits. We're talking quintillions of starting points. And every single one of them, every single one, has fallen into that 4-2-1 loop. But in math, checking a quintillion examples is not a proof. You need absolute certainty for all numbers, and that's the one thing we just don't have.
And that's really what this is all about. This isn't just some abstract math problem. It's a lesson in humility. It's a beautifully simple system that we can all understand, but its behavior is still completely beyond our grasp. It's a powerful reminder that there are still fundamental, seemingly basic truths about our own universe that are just sitting there, waiting for us to figure them out.